Another thing that's worth thinking about, perhaps as an addition to the SCAP after adoption, is adopting a carbon neutrality goal. When the city's 2016 SCAP goal was adopted, California's greenhouse gas emissions reduction goal was to reduce greenhouse gas emissions 80% below 1990 levels by 2050. But in September 2018, Governor Brown issued California Executive Order B5518, setting the goal of achieving carbon neutrality as soon as possible and by 2045 at the latest, and maintaining net negative emissions from that point forward. The state's carbon neutrality target is based on the Paris Agreement, which calls for preventing average global temperature from rising more than 2 degrees Celsius, or 3.6 degrees Fahrenheit, above pre-industrial levels, and pursuing efforts to keep warming below 1.5 degrees Celsius, or 2.7 degrees Fahrenheit, according to an International Governmental Panel on Climate Change report, also called the IPCC, in 2018. Holding temperature rise below 1.5 degrees Celsius will require carbon neutrality by mid-century. The basic definition of carbon neutrality is achieving net zero emissions for the community. This means the amount of greenhouse gas you put into the atmosphere is offset by an equal amount removed from the atmosphere using carbon removal methods like new forest growth and removing carbon from the air and storing it underground. Because carbon removal methods have limited capacity, achieving carbon neutrality requires very steep emissions reductions as well. We acknowledge that this is an expensive effort to undertake, and some might ask whether it might make more sense to try to achieve the 80% reduction target over a longer period of time, say 2040 or 2050. This could reduce the total cost to electrify because more appliance replacement takes place at the end of life, and more new all-electric construction and major renovation, which is cheaper than retrofits, will take place. In addition, the slower pace of implementation would reduce the maximum annual financing cost incurred by the community. However, the cost of delaying emissions reductions is high. In 2018, a special report by the IPCC identified several example pathways to hold global warming to 1.5 degrees Celsius, the level of warming that begins to result in serious ecological and economic impacts. We're currently at 1 degree Celsius, by the way. The pathways they modeled involved slower and faster rates of emissions reduction in the coming decades. But regardless of how fast we decarbonized, each pathway required carbon dioxide removal in some form, with the most commercially ready technologies being some combination of new forest growth and pulling carbon from the atmosphere and storing it underground. These pathways were labeled P1 through P4 in the special report summary for policymakers. Confusingly, they were labeled low emissions development, or LED, S1, S2, and S5 in the main body of the report. The P1 scenario involved the most rapid global emissions reductions and required little carbon dioxide removal beyond new forest growth. The P4 scenario involved continued emissions growth through 2030, then rapid decarbonization and achievement of carbon neutrality by mid-century, but it required massive investments in carbon dioxide removal using expensive industrial methods and underground storage. Staff did a very rough estimate of Palo Alto's share of global carbon dioxide costs based on global and local 2010 emissions under each scenario, just to illustrate how much more expensive it can be to delay emissions reductions. As shown in this chart, the cost of additional carbon dioxide removal increases very significantly the slower emissions are reduced. This is both because much more carbon must be removed from the atmosphere in the slower emissions reduction scenarios, but also because much more of that carbon dioxide removal takes place using expensive industrial processes, since there's a limited potential for new forest growth globally. Alternatively, if no carbon dioxide removal were implemented, the slower emissions reductions would likely result in global warming exceeding 1.5 degrees Celsius, with significant resulting economic impacts that would likely outweigh the savings from delaying implementation. These are very rough estimates, of course, and costs of carbon dioxide removal, and the economic impacts of global warming are highly uncertain and difficult to predict. But while the precise costs of delay are uncertain, staff is confident, based on analyses available in the public domain, in the fundamental insight that the costs of delaying climate action likely outweigh the savings by quite a bit.